Okay, dear all, today I am going to start B+Tree, right? So myself Achintya Pandey, and as assistant professor in Department of Information Technology at Ajay Kumar Garg Engineering College. So let's see what is B+Tree. Okay. Before the data structure which we have discussed earlier, like a binary tree or even tree or graph or even array, linked list, they all refer to accessing in primary memory, right? B+Tree, this data structure is used to access file for data structure. So far we have assumed that we can store an entire data structure in main memory, but we have data that it won't fit. So B+Tree is used to store or access data in disk storage, that is for the hard disk. Okay, how the access time could be minimized and all, this is done by the B+Tree, right? So let's see. The problem is that big O analysis assume that all operations take roughly equal time. This is not the case when disk access is involved. It is worth executing lots of instructions to avoid a disk access. In this lecture, we will discuss what is B+Tree. We will take an example. We will have some simple nodes, many nodes and we will construct B+Tree. Then we perform the insertion and deletion operations. So what is B+Tree? B+Tree is basically balanced MOS search tree, right? So before discussing B+Tree, we are required to know what is MOS search tree. You can say that B+Tree or even MOS search tree is a generalized binary search tree. You already know what is BST. So BST is what? In a binary search tree, every node will have value which will be greater than its left child node and less than its right child node. Suppose if a node having value 5, so this 5 will be greater than its left child node, say for example 2, and it will be less than its right child node, say at 8 or 12. Okay. So how generalized BST could be formed? In BST or even in binary tree, only one information on a node can be stored. If we can store multiple information on a single node, then by doing this we can reduce the file access time, right? We can access any information on the order of h, right? Okay. So let's see first definitions and then we will see. So B+Tree, we can say it is a similar to a binary search tree, or you can say generalized BST. Generalized BST means what? BST or binary tree will have single value on every node, right? And the characteristics of BST is the value at each node will be greater than its left child node and less than its right child node. But in generalized BST means there may be many value on a single node. So that will be generalized BST and the property will follow just like binary search tree. So we can say that B+Tree is not a BST. In fact, it is not even a binary tree. We will see how why it is not. So B+Tree nodes have many, or you can say more than 2 children. Another important property is each node contains more than just a single entry. So what is B+Tree? See, before solving the question of B tree, you have to know, or you can say there are two terminology are used. Sometimes we say B tree of order. One is order and second one is degree. So if we say B tree of order, say for example M, this means B tree will have maximum M child. Suppose if M equal to 5, then we can say B tree will have maximum 5 child. If we say B tree of degree, say for example M, say let's equal to 3. What is the meaning of degree? Degree means if it will have degree 3, means it will have minimum 3 child node and maximum will be its double, like 6. So there will be 6 child node which will be maximum, and there will be at least 3 child node, right? And if there will be 3 child node, means information, or we say key value, will be 1 less than. Means if there are 3 child node, 3 pointer to subtree, then there will have 2 key value, and if here 6 child node, then we'll have information 6 minus 1, that is 5. 1, 2, 3, 4 and 5, right? So the terminology which we require to solve the questions, one is order and second one is degree. Order means maximum number of child, right? Whenever there will be given say order, this means maximum number. Like for example, if you say B tree of order 5, means B tree every node can have maximum 5 child node, right? And if it has 5 child node, then the key value will be 1 less, means 5 minus 1, 4. Now if you say B tree of order if you say B tree of degree, for example M equal to 3, degree 3 means minimum and maximum both. So minimum will have same number of child node and maximum will have double of degree. Okay. Okay. So just go through the point. First see what is with the degree order. So what is B tree? So B tree is basically MOS search tree. MOS search tree have the advantage of minimizing file access due to their restricted height. However, it is essential that the height of the tree be kept as low as possible, and therefore there arises the need to maintain balanced MOS search tree. Such a balanced MOS search tree is what is defined as B tree. As the height will be reduced, the time to get the information at a node will be less. So in the B tree are kind of like MOA, B tree, B+Tree or B star, we will have many information, many key value. So that's why the file access time is reduced. Okay, just go by the definitions and see the point. Say a B tree of order M, right? If it is non-empty, then this will be an MOS search tree, and these all are the some property. The root has at least 2 child. Okay, the root has at least 2 child node and at most M child node. Okay, in these data structure like B tree or MOS search tree or B+Tree, there are 2 things. One is every node will have 2 things. One is key value by which file is searched, and second one is pointer to key value. Means here we put the key value and we can write like this, or even some other term. This is what pointer to subtree, means child node. So if a B tree or even MOS tree, so if the order of B tree is M, then it will have M number of child. Say B tree of order 5, so it will have 1, 2, 3, 4, 5 child node. Now every node, or let's see what will have the root node? The root node has at least two child node. Two child node means key value will be one less, means one key value, and at most m child node. Okay. The internal node except the root have at least m by 2 child node. For example, if m equal to 5, so every internal node means excluding root and leaf node. Say m equal to 5, so the internal node except the root have at least m by 2 child node, means 5 by 2. This is the ceiling function, 5 by 2.5, 2.5 and 2.5, and the value of 2.5 will be 3. Ceiling functions, so we take upper degree. So the internal node except the root have at least m by 2 child node and at most m child node. The number of keys in each internal node is one less than the number of child nodes, and these key partition the key in the subtree of the node in a manner similar to the MOS search tree. And last point is all leaf nodes are on the same level. So these definition you need to require to construct the B tree. First is what? Any B tree of order m will have maximum m child node. So if there are m child node, the key value will be 1 less, means m minus 1. Okay. So just go. You can also take this point by these rule, B tree rule 1 to up to 6. B tree rule 1, the root may have as few as one entry. Every other node has at least minimum entry. What is minimum? We can say it as a degree. Okay. B tree rule 2, the maximum number of entry in a node is twice into minimum. Like if a B tree of degree 3, if we say B tree of degree 3, so 3 will have minimum child and 6 will have maximum child. Okay. 1, 2, 3, 4, 5 and 6. The subtree below a B tree node, rule 4, the number of the subtree below a non-leaf node with n entry is always n plus 1. And for any non-leaf node, an entry at index I is greater than all the entries in subtree number I of the node. An entry at index I is less than all the entry in the subtree number I plus 1 of the node. A B tree is balanced. Balance means what? All the leaf node will have at the same level. It is called balance. MOA tree is not balanced, right? We can insert node and in the all the leaf node are not balanced in the MOA tree, but in the B tree, and that's why we say ki B tree is balanced MOA tree. Okay. So you can see the capacity. If we have 1000 element data array, so we will have 1001 subtrees, and by that we can calculate the number of entries. So let's solve some questions. How B tree can be constructed. In today's lecture, we will take example. By that we will construct B tree. We will insert many more elements and deletion of B tree. So inserting into a B tree. Attempt to insert the new key into a leaf node. Any item which we want to insert will be inserted into the leaf node. If this would result in that leaf becoming too big, split the leaf into two, promoting the middle key to the leaf parent. If this would result in the parent becoming too big, split the parent into two, promoting the middle key. This strategy might have to be repeated all the way to the top. If necessary, the root is split in two and the middle key is promoted to a new root, making the tree one level higher. Let's see what we are required to construct B tree. As we define, B tree of order M. So how you can construct the tree? First, the order of the tree or degree of the tree will be given. If the order of the tree is given, so this means maximum number of, say if saying B tree of order 5 or order 3, the B tree of order 5 means a node would have maximum M child node, maximum. So there are two things. One is key value like this, and second one is how many subtree or pointer to subtree or child node we can say. So if a B tree of order M means that is the maximum number of child node, so every node will have key value. Every node will have key value. Here we put the key value, and this shows the pointer to subtree 1, 2, 3, 4, 5 like this. So this will have the structure of root node or any node we can say. Similarly here, if we want to draw, say we'll have like this node. So if 3 key value are there, so there will be 4 pointer to subtree means child node 1, 2, 3, 4. यानी हर नोड में दो चीजें होंगी, एक तो की वैल्यू होगा और दूसरा क्या है उसके चाइल्ड नोड कितने हैं. तो यदि बी ट्री ऑफ, इफ इट इज बी ट्री ऑफ ऑर्डर एम, so m means number of child node and key value will be one less. So we would require to verify these points, I mean the definitions of B tree which we have discussed. Sorry. The root must be, the root has at least 2 child node and at most m child node. Internal node will have m by 2 child node, except the root have at least m by 2 child node and at most m child node. Okay. So these 2 points and every key partitions. Other property we have, we will see every node will have key value will be in increasing order, right? हर नोड पे क्या होगा, जो की होंगे वो किस में होंगे, इंक्रीजिंग ऑर्डर में होंगे. So let's begin with the questions, then we can understand much simple way. Suppose we start with an empty B tree and key arrive in the following order like this. We want to construct a B tree of order 5. Okay. So by that you can understand how B tree could be constructed. So what is given? B tree of order 5. These all are the key value of that node. So how do we construct? Just see with the question. You can construct any number of B tree. First, 1, 12. What is the B tree of order 5? Means m, the value m is equal to 5. So what is the meaning? A node will have maximum 5 child node. So if 5 child node, then the key value will be 5 minus 1. Means any node, either root or even leaf, could have at most 5 means 4 key value, right? So every node can accommodate up to 4 key value, right? So let's see how we make the B tree. First, these all are the, key values. Okay, how we will construct the B tree? We will construct B tree just like we are inserting one by one. First we will insert 1 into an empty B tree. So how we insert? So 1 means there is a single node, so it will have like this 1. Okay, so if it is 1, so how many pointer to subtree? Child node, it will have 2 like this. अभी यहाँ पे कुछ नहीं है, null है, ठीक. Similarly 12, तो 1 and 12. Okay, 1 and 12. Okay. So by this way, a root node 1, then we could have 12, then third is 8, we can put it here 8. Now every node will have key value always will be increasing order. So it will be like 1, 8 and 12. How many further element can be inserted? One more, because the B tree of order 5, so every node will have maximum 4 key value. Okay. So next we can insert 1, 12, 8 and 2, 1, 12 and 2, but it should be in increasing order. So like this, the node structure of root will have 1, 2, 8 and 12. Increasing order 1, 2, 8 and 12. So the first 4 items go into this 1, 2, 8, 12. Now the moment we get fifth, I mean this one, okay, the node will exceed by its maximum value. Okay. So what we do in that case, if a node exceeds the maximum value, we split the node into 2 equal half. So like this, if we will have 5 value, so which will be the mid element 8. So 8 comes as a parent and 1, 2 and 12, 25 will be its as a child node. Okay. So ये 2 parts में split हो जाएगा, एक part ये हो जाएगा और एक part ये हो जाएगा. Okay. So to put the 5th element in the root would violate condition 5. Therefore 25 arrive. When 25 arrive, therefore when 25 arrive, pick the middle key to make a new root. ठीक. क्यों? क्योंकि B tree का order क्या है? 5 है. So one node could have maximum 4 key value. See, there will have 5 child node, I mean pointer to subtree, but key value will be 1 less. So maximum key value will be 5 minus 1, that is 4. Okay. So like this. So if a node exceed its maximum value, we will find the middle point. So if we consider just as a linear array, so this will have the middle value. So it will become the new root, and this one we have left, this one is right child. Similarly, we will insert one by one. If we get 6, every informations, I mean every key value will be inserted into the leaf node. Now this is the tree up to that point. If we insert 6, where it go? Since it is generalized BST, so 6 is less than 8, so it will go into the left child of this. So we will have 1 to 6. Okay. Then 14. 14 is greater than 8, so it will have the right child value of 8, means 12, 14, 25. Okay. Then 28. Again, 28 is what? Greater than 8, so it will be right child value. Okay. So we can put here 28. Okay. These all are we are up to here. Okay. Further inserting the node. So just see, we have already started. So just we are saying that every node will have key value always be in increasing order. Fine. So let's insert further. Then we will have 17, where it will go. Adding 17, next node is 17. 17 will be inserted. 17 is greater than 8, so it will be the right child of 8, and where it fit 12, 14 means 14 and 25 के बीच में क्या हो जाएगा? 17 हो जाएगा. But this node is at its full position. I mean this node having maximum number of element. So again we will split into its middle. Okay. So middle means if we insert like 17 here, so this will be middle, I mean 17. So this will become the new root. Okay. Okay. So just like, and see, this root will have, I mean, the capacity of up to 4 key value holding, to hold the 4 key value. Okay. So adding 17 here, it have seen like this 12, 14, 17, 25, but this is exceeding. Why? Because B tree of order 5 will have maximum 4 key value. So we'll split this node into equal 2 parts. So 17 will accommodate into parent node. Why it will accommodate into parent? Because it will have just one, I mean, key value. So it can take maximum 4 key value. तो just we can see 8, 17, 17 यहाँ आ जाएगा और ये 2 पार्ट में ब्रेक हो जाएगा. Then next, what is the next element? After 17, we have to insert 7. Okay, 7 कहाँ जाएगा? 8 से 7 will be, means 7 is less than 8, so it will be the left child, and this node is having 3 key value, so it can accommodate. Okay, so 1, 2, 6 and 7. So in the next we can see 1, 2, 6 and like this. This one, ये तो वही है 7. This node can be go here and this 7. Then we will have after 7, what is this? 52. So just see where 52 would be. 52. 52 is what? Any node which we are going to insert, we have to traverse from root, right? Before inserting a node, I mean a key value, we have to traverse from the root, like just like in BST. In BST, what we do? We just compare with the root whether it is the value is, whether the, I mean the inserted node is less or greater. If it is less, it will go into the left subtree. If it is right, it will go into the right subtree. Again, we will compare with the root of that left subtree. If it is less, then it will go into the left and right, like this. So for the 52, we will compare with the root 8, 17. It is greater than 17, so it will have the right child of 17. Okay, so right is having, I mean, 25 and 28, so it can accommodate 52. And further, if we will go 16, 16 is what? 16 is what? See, 16 is lie between 8 and 17, means it is bigger than 8 and lesser than 17. So it will have like this. आप ऐसे भी इसको बना सकते हैं, जैसे इस तरह से बना सकते हैं, जैसे यहाँ पे आप 8 लिख दिया, यहाँ पे 17 लिख दिया, और चाइल्ड को शो करने के लिए आप ऐसे कर सकते हैं यहाँ पे लाइक दिस. सो ये हो जाएगा 8 से छोटा, ठीक. इधर हो जाएगा आपका 8 एंड बिगर देन 8 एंड लेस देन 17, एंड दिस वन विल बी ग्रेटर देन 17. द वैल्यू विच विल बी ग्रेटर देन 17 will be like this. So we can show like this. Okay, so by that way we can insert 52. It will come just after, I mean here we can insert 52, and again if you want to start 16, how we will compare? 16 is what? Greater than 8 and less than 17, so it will come into this. After 14 will come 16. Then 48. 48 is what? Again we have to search from the root. 48 means it is greater than 17, so it will go into this. Okay, so 48, so यहाँ पे क्या आ जाएगा? 48 आ जाएगा, and फिर इसको हम क्या कर देंगे? Sort कर देंगे. After sorting, we will get this one like this. Further, 68, where it will go? 68. 68 is any, I mean, node, or we can say key value which we are going to insert must be compared always with root value. So 68, it will be greater than 17, so it will be the right child of 17. Now here, so this node is full already, so like this we can insert here 68. Why it is full? Because this B tree is of order 5, so any node can can take maximum 4 key value. 5 means 5 child node. 4 key value means it has 5 child node. Okay. So 68 is here. This node is already full because no node can have value more than 4. So what we do? We split with its middle point. So what will be the middle point? This will be the middle point. 2 इधर left हो गया, 2 right हो गया. So this 48 we will be its new, I mean parent. So its parent is already having 2, I mean key value. So it can further accommodate up to 4. So if this 48 can accommodate at this root neighbor. So 8, 17 and 48 उधर हो जाएगा. In the next line. 8, 17, 48. Okay. We have combined 2, 3 steps. Okay. So here we will be 8, 17 and 48, and this will be the, I mean this and this left and right. Okay. Again we have inserted 3. I mean next node is what? 3. 3 where will we go? 3 is less than 8. So this will come left node of this. Okay. See, the value less than 8 will be its left child. The value in between, I mean greater than 8 and less than 17 will be part of this node. The value greater than 17 will be part of this node. Okay. So if any node will have already its maximum value, I am accommodated with its maximum key value, then that node, if further we want to insert, will be broken into 2 halves. Okay. And the middle one will accommodate with the parent if it has, I mean if it is not accommodated with the full key value. So 3, if you want to insert 3, so 3 will be what? 3 will be less than 8. So it can accommodate like this, 1, 2, 3, 6, 7. Okay. So this is also avoiding, I mean this is already more than have maximum key value. So again we will split into equal half, I mean 1 and 2 and 6 and 7. So 1, 2, 6, 7, 3 this will accommodate with this. So 3, 8, 17 and 48. Okay. So by this way we can do. Similarly adding 26, 29. See, if you want to insert 26, how we'll do? This is up to this. So adding 26 is what? Root node is already full. Let's see where it will lie. 26 means what? 26 will become the part of this node. Why? Because 26 value is greater than 17 and less than 48. Okay. So here we could have 26. Similarly 29. Again 29. This 29 is what? Greater than 17 and 48. So this 29 value will accommodate with this node. Okay. And we will finally sort after each insertion. Then we will have 53. How will insert 53? 53 is greater than 48. So this 53 will come here. I mean 52, 68 and 53. Then we will sort. Sort means 52, 53, 68. 52, 53, 68. Further we want to insert 53. So 53 is again, okay, we have insert 53. Now we want to insert 55. 55 is again greater than 48. Any node, any key value which we want to insert always have to traverse from root. First we will identify whether it is left or right or how. Okay. So just to insert 55, 55 is greater than 48. So it will be here. Okay. So 53, 55 and further we will sort. After sorting, what we will get? 52, 53, 55 and 68 like this. Okay, go into the leaf. Then further we have some node, I mean not node, value which we want to insert. 45. See where 45 will go. 45 is what? 45, the value, now we want to insert this 45. So 45 is how inserted? 45 is greater than 70 and less than 48. So this will become the in this part. But this node is already full because it has 4 key value and the order of B tree is 5. So if it is 5, maximum 4 key value will be inserted. Okay. So adding 45. So we will accommodate with this and we will split it. So the middle will be 28. So 28 will goes into the parent and we will split 25, 26 and 29, 45. But parent is already full. So यहाँ पे क्या हो जाएगा ये 28 यहाँ चला जाएगा इसके इंक्रीजिंग ऑर्डर में 3, 8, 70 and 28 यहाँ का ही होगा 28. बट ये फुल से ज्यादा हो गया तो सेम प्रोसेस यहाँ भी अप्लाई कर देंगे. इसको भी हम क्या कर देंगे स्प्लिट कर देंगे. तो 3, 8, 17, 28 and 48 मिडिल कौन सा होगा. So this will become the new root. Okay. So 3, 8, 28, 48, 17 is the new root. So we are just seeing in this example that the tree height grows by 1 in the upward direction. Okay. So like this. Rest will be same. ये भी क्या हो जाएगा ये नोड भी क्या हो गया स्प्लिट हो जाएगा 2 पार्ट्स में 3, 8 लेफ्ट पार्ट 28, 48 राइट पार्ट 3, 8 लेफ्ट पार्ट 28, 48 right part and like this. So one difference in B tree and other tree like binary search tree, in B tree if we are going to insert the tree may grow, a tree grows in upward direction. Upward direction means bottom to top. We have seen that bottom to top it increases, right? So this is all up to inserting. So just summarize how we insert. So a list of values will be given, or you can say the key value. If the key value are given and the order of the tree is given, we will just adopt just like as a insertion of binary search tree, right? But here in binary search tree, a node will have only one key value, but in B tree, a node could have maximum m-1 key value, where m is the order of tree. If in the question it is given degree, say B tree of degree 3 or 4 or 5. So B tree of degree 3 means that node or any node will have minimum value is what 3 and maximum value is double of its that. Anyway, here it is given the order. So it is given the maximum number of by giving the order of the tree we can find how many maximum child node could have and how many maximum key value can be stored on that particular node. So the insertion is over. Okay. Now how we can delete a key value from B tree. Okay. So moreover, the deletion of B tree is just like as a deletion of binary search tree. Just the difference is in binary search tree there are only single value on each node, but here in B tree there are maximum m-1 key value at every node, even in the root or even on the leaf. That's why we say that deletion. So first how we delete in the BST? BST में हम कैसे डिलीट करते हैं? तो यदि लीफ नोड होता है, ओके, सो BST में हम कैसे डिलीशन करते हैं? जैसे लीफ नोड होगा यानी कोई चाइल्ड नहीं है तो ऐसा डिलीट हो जाएगा. यदि 1 चाइल्ड है सो वो रिप्लेस हो जाता है. जस्ट सी, दिस इज द डिलीशन. सिंपल लीफ नोड. Delete, suppose we want to delete 2, so we can delete 2. What condition we are required to check? Minimum. The node, a node will have any leaf, any internal node will have minimum m/2 key values, right? So इससे कम नहीं होना चाहिए. That condition we are required. Okay. So this is the process here given. Delete 52. 52 is a root node, or you can say internal node. So this is not at the leaf, so we can replace with the minimum value of the successor. Okay, so like this. So 52, always a node from the the value from leaf node can be deleted or removed. So if you want to remove, say this one internal node, if you want to remove the value from the internal node, it is just replace. So 52, so it will replace with the 56. Okay, like this. So these are steps given. You can easily find out how it could be deleted. Like this. That's all about B+Tree. Just see the PPT, and thank you very much.